look at another parent graph and its absolute value, okay? So whenever we first introduce ourselves to something, we graph it by just picking some points and seeing what happens. So let's do -3, -2, -1, 0, 1, 2, 3, and see how that works. Wouldn't work out so well for square root, would it? But for this one, it works fine. So what is the absolute value of -3?
3.
-2. -1. 0. 1. 2. 3. Okay, so we come over here and we graph this. I'm going to change color so we can see it a little better.
Oh, this is one of the good.
I get it. It's back to black. I mean, Carter.
We didn't know
Oh,
yesterday.
sorry, Carter. I'll straight. I'll
Okay,
straight.
you're up here. I'm going to go down here.
Okay,
How dare you make fun of me?
so here we go. Alright, guys, there's a lot of extra talking. So let's see if we can curb some of that.
Now, Mr.
And let's look at this because this ends up being our parent graph. So in a little while, we're going to take this parent graph and we're going to shift it. We're going to reflect it. We're going to stretch it. And it's going to be not hard because this just makes sense. When I move left or right from this vertex, I'm just taking the absolute value of my x move. So +1 absolute value is 1. +2 absolute value is 2. -1 absolute value is 1. -2 absolute value is 2. So what is the domain of this function? Negative infinity, positive infinity. Range.
0 to infinity.
0 to positive infinity. All right. Extrema.
0.
Minimum.
We have a min,
At the origin.
and it's occurring specifically at
0, 0.
0, 0. This one also has, and we haven't seen it in a while, maybe not since parabola, an axis of symmetry. So we could draw in a little dashed line right here to represent. Go away. Go away. Why is it there? Okay. To represent our axis of symmetry, and it would go right here, and we could fold the function over top of itself right there. So the axis of symmetry is where?
0, 0.
It's a line. How would I describe it? X equals 0. Excellent. Okay, this function does have increasing and decreasing intervals. So what's the increasing interval?
0
to infinity. Decreasing interval?
Negative infinity to 0.
Negative infinity to 0. And we can talk about the end behavior of this function. All right, so we could say as x approaches negative infinity, what does the function do?
Y goes positive infinity.
Good. And as x approaches
X goes positive infinity.
Uh-huh.
Y goes positive infinity.
y goes positive infinity. And I guess the only other thing we talked about really were the x-intercepts and the y-intercepts. Does this one have any x-intercepts?
Yes.
Yes, at 0, 0, and any y-intercepts?
At 0, 0.
Yes. Okay.
That's something to say.
Any questions about that? All right. I would like you to try these two because these are just transformations of that parent graph. I think you can do it. So let's see what you can do. We have z of x and g of x. And if you'll take just a moment, sketch a beautiful graph and give me the characteristics of those two functions. All right, everybody come back since we're just chit-chatting anyway. So here we go. So number 1, did you put the vertex of this absolute value at 2, -3? And you quickly sketch the V. And you have the correct domain, range, extrema, axis of symmetry, increasing, decreasing, x-intercept, and y-intercept. Okay, so the x-intercept and y-intercept we can also find algebraically, can't we? So to find the x-intercept algebraically, we plug in 0 for the value of the function, make our y's equal 0, and that gives us the x-intercepts. So we get 3 equals the absolute value of x minus 2. Well, when we're solving an absolute value, if everything in here equals 3, it makes it true, right? So if everything in there equals 3, or if everything in here equals -3, because what's the absolute value of -3? 3. So we could say everything in there could also equal -3. Does that make sense?
Yes.
And then solve them. So we get 5 equals x or negative 1 equals x. Is that what I got when I looked at the graph?
Wow.
Yes. Okay, now
I need some protection.
to find the y, you just plug in 0 for x. And so you get y equals the absolute value of 0 minus 2 minus 3. Well, the absolute value of negative 2 is 2, and 2 minus 3 is negative 1. So did we get a y-intercept of negative 1? So we can do it algebraically or graphically. Any questions? Okay, now number 2. So we're going to start up here at positive 4, and because of the negative, what's going to happen?
Reflection
It's going to reflect down, because it took the original and reflected it over the x. And what does the 2 do?
Scale factor.
Our vertical
2.
stretch by a factor of 2. So instead of over 1 down 1, we're going to over 1 down 2. Instead of over 2 down 2, we're going to go over 2 down 4. Okay, so carefully check yours and make sure yours looks like this.
Miss Willoughby,
Yes, sir.
like on number 1, when you're finding the x-intercept, what if you didn't have negative 3? What if it was just x minus 2?
Then you just have one intercept at positive 2, because it would be right here.
Okay.
Okay, so here we go. We know our domain is from negative infinity to positive infinity. Our range is what, guys?
Negative infinity to 4.
To 4. What's the axis of symmetry?
X equals 0.
X equals 0. Increasing?
Negative infinity to 0.
Decreasing?
0 to infinity.
Extrema?
Maximum at 0, 4.
X-intercept?
Negative 2 and 2.
Negative 2 and 2. And y-intercept? Okay, any questions about this? All right, now, those of you that hadn't learned absolute value before wrote your homework answers as piecewise, right here, as 2 lines, didn't you? But do you guys see that this one on your homework, number 6, is actually absolute value? And the way we know its absolute value is the slopes are just going to be opposites. So this slope is positive 1. This slope is negative 1. So this could have, these two could have been written as one absolute value function. You see that?
Make that change.
Because I was ready for it. All right. So do you see that this could, instead of been written as a ray and a segment, could have just been written as one single absolute value function. Okay, I'm going to stand in the back. There are lots of whispering going on today, and I'm talking about some awesome things. I don't want any of you to miss out. So I'm going to sit back here so I can nail you when you start talking now. All right, here we go. So hopefully everybody just got this, that we could write this as 2 lines, where we restricted the domain, or as one absolute value. So let's come and look at this absolute value and see if we can write it as a piecewise. Let's look at the pieces of this. It's 2 rays. What is the equation for this ray?
Negative x.
Negative x. If x is less than 0. Okay, what about this ray? X if x is greater than or equal to 0. Okay? So, let's take a look at this one. Let's see if we can write this absolute value as a piecewise. So, what would this piece look like?
Negative x.
A negative x
Minus 1.
minus 1 if x is
Less than 2.
less than 2. Okay, what would this piece look like?
X.
X
Minus
5.
5.
If
X is greater than or equal to 2.
great. Okay, now let's come over to this one. Could we write g of x as a piecewise? What would this one be? 2x plus 4, and I'm just going to come up under it because I'm running out of space. If x is less than 0, and what would this piece look like? negative 2x plus 4 if x is greater than or equal to 0. Now, yes?
For the first you try, why is the 5 negative?
It would cross right down here at negative 5. If we continue this, you see it would have a y-intercept of negative 5. So to get the equation for the line, it's always mx plus b, so the slope and the y-intercept. So even if it doesn't touch it, we still have to account for it. Okay, now, there's a cool way to do this algebraically too. To get the right side, all you have to do is drop the absolute value. And that gives you the right side of this function. Do you see if I drop the absolute value, I get x minus 2 minus 3? Isn't that x minus 5? Okay? Now, to get the left side, on the left side you change everything inside the absolute value. And then drop the absolute value. And that gives you the left side. So if I changed everything over here and drop the absolute value, do you see I get negative x plus 2 minus 3? Is that negative x minus 1? And that gives me the left side. Let's see if it works over here. To get the right side, I just drop the absolute value. Oh, is that what that is? To get the left side, I change everything inside the absolute value and then drop the absolute value. Does this simplify to this? Yes. So that's kind of if you didn't have the graph, what could you do? So to get the right side, you just drop the absolute value. To get the left side, you change the signs of everything inside the absolute value, drop them, and that gives you the left. Make sense?
Yes.
Okay. So now we know how to write absolute value, and we know how to write absolute value as a piecewise function. Okay. That's what I use that one for. Okay. Now let's look at this. We're going to do a couple things with this. This is one of the ones we just looked at, and here is the same graph we just graphed just a minute ago. Okay. All right. So the first thing we're going to do is we're going to find out where this function equals negative 1. Where does this function equal negative 1? What can I do with a graph to figure that out, guys?
Look at this.
Look where the function has a value of negative 1. Where does it have a value of negative 1?
0 and 4.
Right here and right here, doesn't it? So we could say at x equals 0 and x equals, what's the other one? 4. So if I gave you this equation, negative 1 equals x minus 2, the absolute value of x minus 2 minus 3, can't we see from the graph right here that happens at 0 and at 4? Okay, now could we solve this algebraically? Sure we could, but if we already have the graph, let's just look. But to solve it algebraically, you'd move the 3 over. Okay, so if all of this stuff equals positive 2, it's true. And if all of this stuff equals what? Negative 2, it is true. Because the absolute value of positive 2 is 2, so when I plug that in, the absolute value of negative 2 is 2. So do you see I get x equals 4 and x equals 0. So whether I do it graphically or algebraically, I got the same answers, didn't I?
Yes, you did.
Okay, now let's do another thing. Let's find where z of x is less than or equal to 1. So could I write this like this? Not 1, that? We can just look. What is that interval over which that function is less than negative what?
1 to 4. 0.
0 to 4. Okay, let's do greater than. What would I be looking at now? Above. So I'm looking up here and over here. That's above the line, isn't it? So what would that look like? So that would be from negative infinity to 0. And then what? 4 to infinity. And how do I show that both of these go together to be the answer to that? Union. Okay? So that's how we would use the graph to do this. I like the graph. It's nice and easy. We can see it all. We don't have to do much thinking. What if we didn't have the graph? What would we do? So if we'd have to do some algebra. So if we didn't have the graph, we do the algebra by moving this over. And so when we move that over, we get 2. So does it make sense that it would be between negative 2 and positive 2 to make something true here? So all of this is less than negative 2, is less than 2, or greater than negative 2 to make this true. It's actually and. So we get x is less than or equal to 4, and x is greater than or equal to 0. Could I write that as a compound? Yes, I can write this as a compound, which gives me that same interval, doesn't it? So that's how we look at it algebraically. Now, with it greater than, to be greater than 2, this would be greater than 2, or if I threw something negative in there, it would have to be less than negative 2, wouldn't it? Because if I took the absolute value of negative 3, isn't that greater than 2? Okay, so all of this would have to be greater than 2 or less than negative 2, or. So we get x is greater than 4, or x is less than or equal to, whoops, where did the equal to come from? Sorry guys, can't throw that in for no reason. Less than 0. And we can't write that as a single because it's going in opposite directions, isn't it? It doesn't come together. We can't write it as a compound inequality. That's the best we can do. Okay? All right. Your homework is this book work, and in case you didn't bring your book, there it is. And then there's a worksheet. And I'm going to pass out the worksheet, and you have the rest of class to work on it. And remember, class is a little longer because we have no IF today. So you've got until 11:55. So that gives you 15 minutes.